Welcome back to chapter 7. And this is the fourth part of chapter 7, wherein we have been discussing about the 22 types of interfaces. A quick recap of the first part is that we saw the first type or the initial type of interfaces that were designed using the command line interfaces. The user had to remember the commands, the listings, and they have their own research and design considerations. Then the evolution over CLI was graphical user interface, also called as GUI, and wherein the user had the options to work with the graphical things like buttons and list and text area checkboxes. In using the graphical user interface, the user got the chance to uh, r- to to recall than to remember. So there was no need to memorize the commands for saving and exiting the applications and so on. Later to that, we got the web-based interfaces wherein the different form elements can help the different form elements can help the user to navigate to the different parts of the website inside the browser. In the second part of the videos, in the second part of the chapter, we saw that there's something called as breadcrumbs. And if you want to get into the details about it, please visit the video for the part two, and you will learn about each one of them. We got the virtual reality, mobile interfaces, and multimedia interfaces, and the interfaces that are needed for the home appliances, wherein we want to display the possibilities the user can do with this home appliances in a very small area. For example, here you see there is a bread toaster, and it has an interface with the regulator to regulate the intensity and the start with the stop button. And in the third part, we saw about more sophisticated and the recent inventions of the interfaces in HCI, where we talk about tangible interfaces, touchless interfaces, shared screens, and uh, the haptic interfaces like having or creating the touch of Vibro tactile interfaces, wherein the user get the chance of meeting with a device or interacting with a device with a sense of touch or vibration. We also talk about the smart pens in the third part. In the fourth part, we are going to talk about the Vox box, and we're going to talk about augmented reality. We are going to talk about augmented reality, wearable devices, Google Glass, robots, and drones, along with the brain interfaces and smart interfaces and changing shape interfaces. The interface changes over the time, so changing interfaces and holographic interfaces. So let's start over with the first slide. Voxbox. Voxbox is a type of a tangible system that gets the opinion from the user at the time of maybe a party or during a shopping mall time. So basically it is designed to take the opinion of the users at the event to a engaging or a playful interaction. For example, you see there are some balls, and then the user gives his or her opinion by using the vox box. Research considerations include what type of conceptual framework to use. For example, here this is a conceptual framework wherein the user, if she is a female, she will select this button and then do the interactions and play with it and give the feedback. So constructing a constructual framework according to the event is a challenge that has to be taken care to include what specific features inside this feedback mechanism. What kind of coupling to be used between the physical action and the digital effect? Whenever we are talking about the tangible interfaces. The tangible interfaces allow the user to make the physical interaction into the digital world. So maybe changing a color or changing a physical, a ball or something would, change the color and show the feedback. So it's like whenever the user creates, does a physical action, a digital effect is created. So, what type of coupling should be there? For example, if we have seen that magical cubes in the third video, wherein the magical cube changes the colors based on the movement. If the movement is slow or the user shakes the box fastly or slowly, it gives a feedback by changing the color. So this association has to be done carefully in a meaningful way. So it's supposed a quick learning for sure, and then the entertainment. There is a more factor of entertainment inside it, and the designer also have to take care about the physical artifacts to use. For example, it could be bricks or cubes or other components. Here we saw there are balls, and then there are boxes. So the designer has to take care about the physical artifacts that he will use, like cubes or bricks or other components, to make the feedback system simple yet flexible. Stickies and cardboard token can also be used for placing the material onto the surface. With it, so these are the design considerations, the design issues, and the research things. With what kind of digital output should tangible interface be again combined? So for example, here you see this is a digital output. This is a digital output. So what kind of digital output? Here also there are some, lights and things coming. So a screen is displaying something. So what type of, what type of we need to have a digital output for a tangible interface, and we need to have a physical action as an input. So these three things work together actually in the Voxbox. The user creates or gives an input using a physical action, and then to the tangible interface, and the tangible interface then creates the sorry then the user creates the user creates a physical action to the tangible interface. The tangible interface then creates a digital output. So there should be a proper, connections and associations between these three to make a meaningful feedback to the user. Augmented reality is very widespread these days, wherein the um, the physical things are represented in real through some digital effects. Now let's see what are they. Digital representations are superimposed on physical objects on the environment, and and to the user it feels like there is the representation or the object exists in real. A game called as Pokemon Go made it a household game, mostly used with a smartphone or a camera and a GPS to place virtual characters onto the objects in the environment as if they are really there. Many other applications, including medicines, navigations, air traffic control games, and everyday exploring, includes augmented reality these days. In medicines, virtual objects, for example, X-rays and scans, are overlaid on part of the patient's body to see it in the to read, to help the doctors read it in the proper way. It aids the physician's understanding of what is being examined or operated. In traffic controls, dynamic information about artifacts overlaid on the video screen, showing the real planes and so on. We will see this, in the next slide, and so on, landing and taking and taxiing of the plane. So it helps identify planes difficult to make out. So it will help the place to identify the difficult things to make out. For example, here you see an augmented reality overlay on a car windshield. So this is the car windshield, and then you see there are some, for example, here the augmented reality is showing that there is a restaurant here, and then it is showing you the speed or some markers of the speed, and then here in the augmented reality it's showing some kind of images and there is a restaurant open here, for example, after 100 kilometers. So this is an augmented reality. Things appears as if they are in real. They are just a representation, digital representation of things. Okay, so devices for viewing the AR. Augmented reality cannot be easily viewed to the bare eyes. It needs some glasses. So they are called as augmented reality glasses. Okay, so for example, the Snapchat AR spectacles are the examples of it. Smartphones are also the examples of it. For example, we have also seen, when in the Zoom meeting, we have some augmented reality images like this appearing. I will try to open. So and when you're making a meeting, for example, uh, when you're making a meeting, you can change the uh, the background, for example, right? So this is coming from the augmented reality. And where do I do that? This is for annotation. This is for apps. And we see go to the more. Uh, Disable sound, floating meeting, hide the clip. Okay. Mm-mm. Augmented reality, you would have seen, when the uh, like uh, 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 you might see that so many AR filters are available to apply on Snapchat or with Zoom and change the faces. These are all augmented reality related things. So let's get back to the slide. Uh, yeah. Headsets can provide a more immersive experience, but the downside is that they are, difficult to wear. They become like heavy on the head, so it's difficult to wear and fiddle to calibrated. Convenient and easy to use wearable AR glasses are also getting available in the market. AR that uses forward facing camera enables the virtual try-ons, for example, the zoom filters that we saw. It can make the changes in the part of the face. We have 80 mirror setup in reality stores, which helps, for example, like Mac Makeup, they have their app using the virtual reality. They have their some of the beauty companies, they have the 80 mirror equipped to show the effect of sunglasses or jewelry or the makeup things. Convenient, engaging, and easy when compared with to compare with more choices, but cannot it can change the physical appearance, okay, and the physical characteristics. However, we cannot get the weight, texture, smell of what you're trying to um, experience or what you're going to try. So these are the downsides of artificial augmented reality. Can be used to enable users to step into a character. You can step into your favorite character, for example, in Queen Victoria, and see how you will appear in her set, in her, get up and setup. So singers, here is an example of, two celebrities. It's two characters. They are trying to perform in an opera and they want to see how the makeup will look at after, trying it out. They want to see it before. Research and design considerations include what kind of digital augmentation you want, where and when in the physical environment you want to do this, what do you need to stand out, but not get distracted from ongoing tasks. It needs to align with the real world objects. For example, we were trying to show the restaurant on the car windshield. So we tried to use a burger with that in one of the slides, right? For example, here we wanted to show that there is a fast food center. So this is the image that we used. So So it has to be aligned with the real world objects. Okay, use a proper image for showing the real world object. What happens if the AR is slightly off? What should, how to handle it? For example, if the augmented reality is not getting loaded or it is not getting working, so how you will take care? There should be at least a text message or some indicator to show what the AR was trying, and then it couldn't display. What kind of a device you would use? For example, smartphone, tablet, headset, or what? So wearable devices, first developments were in the wearable devices, we had head wearable device and eye mounted cameras that could enable user to record what was seen and to access digital information. Since then, jewelry, head mounted caps, smart fabrics, glasses, shoes, and jackets all have been used now. It provides the user with the means of interaction with the digital information while on the move. And Google Glass is a very excellent example of the eyewear. Application includes automatic diaries, tour guides, cycle indicators, and fashion clothing. For example, here in 2014, Google Glasses were developed, wherein they had so many options to do, but because of the privacy issues, it was somehow stopped. For example, it was designed to look like a pair of glasses that can be worn on the eyes, like a glasses. Okay, so but with one of the lens, one of the lens of the glass being an interactive display with an embedded camera that can be controlled with a speech input. It used to allow the person who is wearing it to take photos and videos on the move and look into the digital content related to that, for example, or not related to that, and even the user had the chance to access the emails, texts, and maps. The user also got the chance to um, uh, do the web search using voice commands and see the results on the back of the screen. A number of applications have been developed to work with it. The popular was Watch Me Talk, that provided live captions that help the wearer or the hearing impaired person to listen to the news, and preview for the glass that enables the wearer to even watch movie trailers. So it was also possible to read about some person or Google about some person the wearer is talking with. And for example, if I'm wearing it and trying to talk with you, I can easily go and search web on the go by looking into your Facebook account, by your, LinkedIn account, and so many other things I can read when I'm talking to you. And when I'm, meeting you for the first time, I can get everything details about you when I'm talking to you. But this kind of, and for the other user, it will appear that I'm meeting you for the first time, but I can read everything about you and even I can record. This actually created some kind of discomfort and the privacy issues. So it was ultimately stopped. The research and the design in shoes for a wearable device is, of course, the comfort, the hygiene. It should not create any infection, and it should be washed and reuse properly once it is worn. Easy to wear and usability. These are the design considerations that have to be taken care. Now we talk about the robots. Remote robots robots are used in many places, right? Especially in places where there is, a danger in the form of hazardous settings. Remotes can be controlled to investigate bombs and other dangerous material. Domestic robots can help the people who do the daily chores in the house. Pet robots can give a company to the human beings, and social robots can work collaboratively with the humans and encourage the social behaviors. Here is an example of two robots. Here, this is a digital pet. They are social robots. They were named as Mel and Paro. They were cute and cuddly, can open and close eyes and make sounds and movements and engage the user. Drones, now the other type of the device what we are going to see the drones. It is unmanned aircraft means the man does, the man is not sitting inside it. It aircraft that are controlled remotely and used in a number of contexts. Medical supplies, groceries, carrying drinks and food to the people at the festival and the parties are the common jobs taken care by the drones. Constructions and art are agriculture applications such as flying them over the vineyards and field to collect the data about the crops is one of the job. For example, here you see this is a vineyard and the drone is, going and checking the trees and the waters and how they are growing and all can be seen. It can also be used in firework displays, helping to track poachers in wildlife parks in Africa. Was their job also once, can fly low and stream or click photos to the ground station where images can be stitched together into the maps. So this is, one of the interesting job that drones does. Can be used to determine the health crop or when it is the best time to harvest the crop. For example, you see the drone can go very near to the farm tree or vine tree and see the crop is ready to harvest it or not. The design considerations the HCI professional has to take care about. How do human records to the physical robots designed to exhibit the behaviors? For example, like making the facial expression compared with the virtual ones. Should the robots be designed like a human being or like a robot kind of a machine? Should it interaction be designed to enable people to interact with robot or as if it was with another human being or more computer like things, for example pressing buttons or issuing commands, or you just communicate with them with the talks? Is it acceptable to use unmanned drones to take a series of images or videos of the field, towns and private property without permission or people knowing what is happening? So these are the design and the research consideration the HCI professionals should take into consideration while creating those interfaces. Computer brain computer interface, also called as BCI, provides a communication between person's brain waves and external device. For example, in my brain, if I'm thinking to move this cursor or change the color on the text, the brain interface is designed such a way that it understands my intention and not intention. It understands my, you know, my idea, and then it tries to implement it with the device. Persons Person should be trained to concentrate on the task. For example, moving the cursor. BCI works through detecting changes in the neural functioning in the brain. So the neurons work in the brain, and the BCI captures or gets the idea by tracing those neurons functioning. BCI apps includes games enable people who are paralyzed to control the robots and do the work. And we had, Stephen Hawkins, like a great great physicist, sorry. So he used to work with BCI and he had his computer. He was paralyzed, he cannot move his hand and legs, but he used to have, a great brain. So the BCI, he used the BCI computer to convey his ideas, and the computer used to write for him and talk for him. A BCI interface is usually mounted on the head of the paralyzed patient, and here is an screen. What she's thinking of is getting written here. How did you travel with your family? My family gave me, and then all. She's trying to write it here. And BCI is helping it. Design consideration: what is the best way to lay out the letters on the digital screen so that the targeted space of the letter is significantly wide enough to allow for it for selecting BCI. Okay, so it means that, because you see here, she is thinking about something and it is getting typed. So how much bigger or smaller display area should be? Ethical concerns are raised by BCI interface that are being developed to work out what someone is thinking. These days, we also have a lie detector, right? A lie detector is also kind of a brain computer interface, wherein the lie detector device is mounted on a user, and then some questions are asked, And if he gives the correct answer or he lies, it is detected. So is it ethical to do that? So we have ethical concerns because brain can think anything, and then understanding what a man is or judging the man based on his thinking should is not that is not ethical, right? So, but because we want to use it in special cases like paralyzed people or, mental people or, uh, you know, or crime makers. So, it is helpful, but however, it raises the ethical concerns. How accurate is PCI in what it infers to be someone's thoughts? How accurate it is? Is it going to give you the correct answer always or not? Then we have smart interfaces like phones, speaker watches, cars, buildings. Even the buildings are smart buildings nowadays, and cities are also smart cities. So, they refer to have some intelligence and connected to the internet and other devices. Context awareness is a very important part of the smart cities or smart interfaces, which understand what is happening around them and execute appropriate actions. For example, a Nest thermostat, or for example, a smart car. A smart car can drive itself, okay, and then there are the cameras mounted on the four sides of a car, which takes cares about saving it from an accident. So if another car comes very near to this car, then the camera and the distance calculation is very important, which is a part of a context awareness. It must know what is happening around it to take some actions. Human building interactions, HBI buildings, are designed to sense and act on the behalf of people staying inside it and control and have some control and interaction with the automated systems. So, for example, a building can be designed in such a way that AC gets off when there is no human being inside it. And then we nowadays we also have on the streets we have solar lights, and they are equipped with a sensor. They get recharged uh, in the daylight, and then in the night, if someone is passing through the pathway, it opens by itself, and then after the user passes away from there, it closes off by itself, it switches off by itself. Research and design consideration. Much research is concerned with human values, needs, priorities, and addressing people's interaction with the smart environment. Uh, Smart interfaces amplify actions and remain attentive to our goals. Or are they becoming, automatic, autonomous? They are working on their own, or they are taking the input from the user, or they are involving the humans in some way, or they just started, for example, as I gave you, the street light should switch on when the user, when some human being is passing by it, and it should close or switch off when the user passed. So the switching on and the switching off should depend on a human, interaction with it by passing or standing below the slides. However, it should not get automated, like, for example, switching on by itself and switching off by itself whenever it wants. It shouldn't be like that. It has to do the work according to the context. Do we need more metaphors to understand and use the smart interfaces? And if yes, what kind of metaphors do we need to have? Another approach is to imbue smart technologies like speakers and robots with the personalities. It can prompt user trust and acceptance, shaping changing interfaces. Uh, this is, a different, an entirely different kind of interfaces that we don't use in our daily lives, but yes, they exist and they help a lot. Use physical shape change as input and output to the system. For example, physical 3D bar charts that is positioned in a grid where a matrix of 3D rods move up and down to convey changes in a digital data set. Or we can have some shape changing interfaces in chemical laboratories also. that can show us some 3D, molecular changes based on the chemical experiments. These kind of dynamic physical representations have been found to help people with the visualization task. Wherever we want to visualize things, these are very great things, very, very great interfaces to help us out. Shape changing interfaces have also been developed as a form of dynamic material to explore novel interactions and possibilities. It provides a different way of interacting with content compared with reading and touching the digital displays. Now we'll see this in the slide. Yeah, you see here there is a grid, and then we have a 3D bar chart which changes according to the user interactions. Uh, Physicalization, artifacts that are designed to encode data in a specific materials are important. An example of Physicit, which is a physical digital system comprising of set of physical cubes that convey digital properties and program to visualize real-time environment data inside the home, is also invented. Benefit of this is to make data more accessible and enable people to readily connect with the context in which the data set is being collected or change over time. Research considerations uh, provide new opportunities for experiencing and exploring data by touch or by sight, by seeing it. But does this facility enhance understanding and engagement with the data set? Yes, I feel like, for example, if we have a 3D uh, interface or a 3D such system wherein it makes me understand the chemical compositions or chemical reactions possible, I can easily understand, right? Design consideration include what is the size of the grid, rod size, and how the design will change. Holographic interfaces. It creates an illusion of a 3D person being present through using various forms of trickery. Uh, Advances in the projection and display the technology have enabled these kinds of digital representations to appear quite convincing. The proto systems let people beam themselves to a remote location and interact with the people there. So this is happening like holographic interfaces can create a 3D representation of yourself and then present you in the class or in the exam and feels like you are there. So the show is talking. This is talking about a show, Ava Voyage, first launched in 2022, features avatars dubbed as Avatar, depicting the group as they appeared in late 70s. So the technology used includes a 65 million pixel screen and in motion capture technology. So here is like, for example, you see here, this is the show, and then all the characters inside it are like avatars. They are not real. So this was the screen created for Abbas holographic projection. Research design issues includes answering questions like, what is the best way to represent people in the virtual space so they feel comfortable and engaging to react with? Feel natural and do not appear creepy. Design considerations include what size the holographic should be and how others viewing them can interact and communicate with those being projected into their spaces. Which interface should be used? We have now talked about and discussed about 22 types of interfaces, and we have seen many types of interfaces that are greatly useful in specific fields. So, as an SCI professionalist, what interface to select for which type of work is a big question. For example, like which interface to use will depend on the task, user, context, what is the cost limitations, robustness, and so on. Is multimedia better than tangible interface for learning? you have to decide and select one. If the cost is less, go for multimedia. If the cost is more, like if you have cost, you do not have limitation on a cost, go for tangible interface. The user can touch and see and experience and then learn. Is speech as effective as command-based interface? Speech for me looks more effective than command-based interface because I will talk and the system will work on it. Multimodal interfaces more effective than monomodal interfaces. So, having only gesture or having only gesture interface or having speed gesture touchless interface can be more effective, for sure, right? Will variable interface be better than mobile interface for helping people to find information in the foreign countries? Are virtual environments the ultimate interface for playing games? Are shareable interface better at supporting communication and collaboration compared with using network desktops? So these all will help you to select one interface for your task or demand. Now summary. Many innovative interfaces have emerged in the last 30 years, including speech, wearables, mobile and brain and tangible interfaces. This raises many design and research consideration the designer has to take care. For example, how best to represent information to the user so they can carry out ongoing tasks or activities. New smart interfaces that are context aware and monitor people, raising new ethical issues concerned with what data is being collected and what is used for. So, this is about the chapter 7, and the chapter 7 is actually quite lengthy. And if you see, all these are uploaded in the um, Blackboard. We have uh, 7 parts for chapter 7 interfaces, and all of them are very important for you to know. So, thank you for watching.